Hello everyone, in this tutorial I'm going to introduce the concept of polar coordinate system. A polar coordinate system is a two-dimensional coordinate system where every single point on the plane is defined by its radial distance from the origin and also the angle subtended or the direction towards that point. So I have a Cartesian plane here and I also have a polar plane. So let me pick 2 points at random, 2 similar points. Let's assume we have a point right here and also a point right here. Let me start with Cartesian plane because most of us are familiar with this. So this particular point is defined by what? X and Y. Every single point on this is defined by X and Y. While this one is defined by r and theta, I'm going to explain all of them. Coming back here, what is x and y? X here is the horizontal distance, which is perpendicular to the point. So for instance, if you want to define this point, you have to start from the origin. You walk towards the right-hand side till you reach a point which is perpendicular to that point. Then you stop. You notice the number of units. Then y here is the vertical distance. You keep on moving vertically here till you reach a point which is perpendicular to that point. So the number of units there will determine the value of y. So every single point we use numerical values to define the point. For instance, if you look at this one, if you move to the x, or let me say the horizontal axis, you can see x here is 1. But here the point is 1, 2. So it implies that at this point we have 1, 2. Let me pick another point at random. For instance, if I have this point, you see that from the origin you move to the left hand side. If you move to the right hand side, you encounter positive values, right? As you move to the left, you encounter negative values, talking about x-axis. And the y-axis from the origin, if you move down, all values are negative, and upward, all of them are positive. So to define this point, you have to first of all move a horizontal distance perpendicular to the point. You can see we have -1 here. This is 1, 2, 3. This is -3. Therefore, to define this point, you have -1, -3 on a Cartesian plane. But what about this one? Unlike in Cartesian plane, every single point here is defined by a radial distance from the origin. R here is the radial distance. And what is this? It means it is the measure of the length from the origin to this point. Straight. Yes. And sometimes we call it radius, right? We're talking about cycle. Then angle here, which is the theta, it is the direction from the what? Polar axis. Remember, we used to call this one x-axis, right? This is x-axis, but we call this one polar axis. So you have to calculate that angle from the polar axis like this, counterclockwise, to reach this particular point. So for instance, if I should draw a dotted line here, this from the origin, which we call the pole, you know, here we call it origin, but in Cartesian, in polar plane, we call it the pole. That is this particular point. The origin is called the pole, while the positive x-axis is called the polar axis. So the distance from the origin to this point is called r. And that angle subtended from the polar axis down to that point is called the theta. So you can see that we have other ways of defining the same point because these are exactly the same point, right? You can see this one is under 1 and 2. This is why we have 1, 2 here, right? But in polar coordinate system, we don't call it 1, 2. Rather, r, which is the distance, I don't know it yet because you have to compute. If you are given a point in Cartesian coordinate system, you have to convert it to polar coordinate system before you write. But just near looking at it here, I may not be able to say this is the angle and this is the distance from the origin. But this is how it is being defined. It is defined by the radial distance. R here is the radial distance, and theta is the direction. So what differentiates this and this? Every single point on Cartesian plane is unique. This is always -1, -3. But this is not exactly the same here, because look at it. We have a point here which we call r, theta. But what if you decide to move around? You come back to where you started. You have added a complete cycle. Remember, in trigonometry, we have so many coterminal angles. For example, if I have 30 degrees here, assuming that this particular point is at 30 degrees, what if you decided to move from here and come back to exactly where you started? You have added 360 degrees. So since initially you have 30 degrees plus 360, you have 390. So it can also be called 390 degrees, though the measurement is not the same, but talking about ratios, they have the same ratios. So also this point can be defined as r, theta plus 2 pi, talking about radians, or 360 degrees. But in Cartesian plane, all points are unique. You don't change them. So this is the introductory aspect. To define any single point, it is what? The measure of the radial distance, then the direction, which is the angles obtended. That's what defines every single point. That's what you should know. Then, what is the relationship between this and this? Because sometimes you may be given a point in Cartesian plane and you'll be asked to write it in polar coordinate system. So how can you do that? So there are some relationships you should know, because in this tutorial, I'm not going to do much. Let me bring down this. You may have a distance from the origin, so you can easily form a right angle triangle here. So let me bring the right angle triangle. The distance from here to here is determined by x value. The distance from here to here is determined by y value. But you know that in polar coordinate system, we are interested in this distance, this particular one, and also this particular angle. So assuming you are given x and y, because that is what you will always be given in Cartesian plane, how can you convert it to this one? Observe, this is a right angle triangle. So what is the relationship between r, y, and x? R is always greater than 0, right? It is always greater than 0. So sometimes you may have or equal to 0 at a point that is on the pole. So assuming it is greater or equal to 0, what is the relationship? Hypotenuse squared is equal to this squared plus this squared. So therefore, in general, we can say that r is equal to the square root of x squared plus y squared. So whenever you are given points on Cartesian plane, you can square all of them, put them inside square root, evaluate, and it will give you the value of r. But what about theta? We know that tangent of theta is equal to what? Opposite divided by the adjacent. Opposite divided by the adjacent. Which implies that if you're looking for that angle, you can easily take tan inverse of y over x. So if you are given a point in Cartesian plane, compute for this to get your r, then compute for this to get your angle. You see that you can easily convert from this to this. And if you are given this, you can also reverse it to get this one. There is another relationship you should know. If you have sine of theta is equal to what? Opposite divided by hypotenuse. Sine theta is equal to opposite divided by hypotenuse, which implies that y is equal to r sine theta. Another one. And if it is cosine of theta, it is equal to what? Adjacent divided by hypotenuse, which implies that x is equal to r cos theta. In case some other points were not given, you can also apply this. So y, which is this one, is r sine theta if you want to convert it to that other one, and x is equal to r cos theta. So I think these are some of the relationships you should know, because in our next tutorial we're going to look onto how to convert points from Cartesian coordinate system to polar coordinate system. Thank you for watching. Do share to your learning colleagues till we meet in our next tutorial. Bye bye.